Hi there, welcome to a review on linear systems and systems of inequality. Alright, so our first question today. Here we have a picture of a graph, and the question is asking us which system has a solution of 0, -2. Well, I know with a system of equation that the solution is at the point of intersection. So if I look here at 0, -2, 0, -2, that point is right there. Well, which lines are creating that point of intersection? Well, if I follow this line down here, that point is on that line, so B is part of that system. And if I follow this line, that point is also on that line, so C. So the system is comprised of lines B and C. Lines B and C. Number 2. How many solutions do lines A and C have? So what it's saying is, how many points of intersection do lines A and C have? Remember, the solution has to be on both lines, which means that's going to be where they intersect. So line A is this line right here. Line C is this point right, or this line right here. So when I look at just those lines, lines A and line C, I see that there is one point of intersection, so there is one solution. One solution. All right, number 3. Which pair of lines is the graph of the system of equations? Okay. Well, here I see that I've got 2 equations and I've got 3 lines. So I want to know, well, which lines are actually part of this system. So really this is just graphing lines and working backwards. So if I take this first one here and I put that in slope-intercept form, if I add 5/4 x to both sides, I get y is 5/4 x minus 2. Well, that means I have a y-intercept of -2 and a slope of 5/4. So I just want to see, well, which line matches up with that. Well, intercept of -2, that's right here. So now I'm down to one of these 2 lines with a slope of 5/4. So if I go up 5, 1, 2, 3, 4, 5, and over 4, 1, 2, 3, 4, that lands me right there. So both of those points are on line C. Line C. I do the same thing with my other equation. Put that in slope-intercept form. So y equals 3x minus 2. Here I have an intercept of -2 and a slope of positive 3 right here, positive 3. So again, my intercept is -2, positive 3, 1, 2, 3, 1. 1, 2, 3, 1. That lands me on line B. So lines B and C are part of that system. Number 4 gets us thinking about substitution. You want to use substitution to solve the following system. What should you substitute for t in the second equation? So let's think about what that's asking us, because this is a different way to ask this kind of a question here. So in the second equation, I want to substitute in t. Well, if I want to plug in for t here, that means I have to solve my first equation for t. So if I take that and I just add w to both sides, t equals w plus 12. That is what I would substitute into the second equation. All right, let's get into actually solving here. Solve the following by graphing. So here I have a system of equations, and these are nice because they're already in slope-intercept form. So when I look at my first equation here, I see I have a slope of 3 and an intercept, oh, I did that backwards, an intercept of 4. Okay, so I'm going to 1, 2, 3, 4 plot my y-intercept. Remember, 3 means 3 over 1, up 3, positive 1, up 3, 1, 2, 3 over 1. Or it can mean 1, 2, 3, 1, right? It can go either way. Use your rulers. Sorry about that. Use your rulers to graph. Make sure your points are precise as you can get them. Now let's look at our other equation. Here I have a slope of -2 and an intercept of -1. So if I'm at -1, my intercept, remember that means down to positive 1 direction, okay, 1, 2, 1, or it can mean up to -1 direction, 1, 2, 1, okay. And right away I see that I have a point right there that's going to overlap. Okay, remember that solution to the system is always at that point of intersection. So that point right there that lies on both lines, -1, 1, -1, 1 is our solution. Now remember, we can check that. You can either check it by hand or you can check it just using your calculator. So if y is 1, that means if I substitute x 3 times -1 plus 4, I should get 1. And I see that I do. Okay? Same thing here. Remember, your solution has to work into both equations. So -2 times x, which is -1, not plus 1, -1, that should also equal 1, and it does. All right? So make sure you check to make sure that solution is actually working for you. Number 6. This one says to solve by substitution. All right, by substitution. Make sure you're using the method that is indicated. All right? Now, a substitution, the first part is to make sure that you have one equation that is solved for a single variable. In this case, I already have an equation that is solved for y. So it makes sense to take this one and substitute it into my other equation. So 3x plus y, instead of y, I'm going to say 5x plus 7 equals -9. When I simplify that, that's 8x plus 7 equals -9, where 8x is -16. So x equals -2. Now remember, if I started using my first equation, when I go to substitute my -2, I need to go into my other equation. So y equals 5 times x, or 5 times -2, plus 7. So that's y equals -10 plus 7, or y equals -3. Ordered pair for your final solution. And then let's go back into our calculators and check. Okay, where can I put this? Here we are. Okay, so 3 times, we had -2, plus our y was -3. Okay, that's substituting in my ordered pair into our equation here, and I should get -9, and I do. So the first one's correct. Second one, I should be equal to y, so I should be equal to -3. So 5 times -2 plus 7 is -3, and that's what my y value is. So I know that I'm correct there also. Number 7, solve by elimination. Again, you've got to make sure that you can solve by the method indicated, right? With elimination, we're going to be eliminating one of our variables. So this one's nice because I see right away 5x minus 5x is going to eliminate. It's going to be 0. Negative y plus 4y gives me 3y, and 8 minus 17 is negative 9, so y is negative 3. I can take that value of negative 3 and plug it back in to either one or the other because I haven't used just one, not like with substitution, right? So I'm just going to go back into the first one there. 5x minus negative 3 equals 8. So that's 5x plus 3 equals 8, where 5x equals 5 and x equals 1. So I've got 1, negative 3 for my solution. Again, you should use your calculator to go back in and make sure that that actually works. That's the best way to make sure that you're correct, is just to check it with your calculator. So in my first equation, I'm going to plug in my x and y. 5 times 1 minus negative 3. And I get 8, and I should get 8, so that's good. Next one, negative 5 times 1 plus 4 times negative 3 gives me negative 17, and that's what it says I should have. So again, I've verified that my answer is correct. Number 8, solve by elimination. Now this one's a little bit different because I do need to eliminate a variable, but I don't have any variables that eliminate right off the bat. What I do see is that I have a 7y and a 7y, so if I multiply one or the other by a negative 1, in this case I'll do the top by negative 1, that's going to give me negative 7y. So I'm just going to rewrite that. Negative 1 times x is negative x. Negative 1 times 7y is negative 7y. That equals negative 12. Don't forget to multiply every single piece there. Okay? Don't forget. And then my other equation just comes on over because I haven't changed anything there. I'm just going to copy it over the same. And then I see that my 7y's now, they eliminate. They cancel each other out. Negative 7 plus 7, that's 0. So negative x minus 2x is negative 3x, and negative 12 plus 18 is positive 6, so that x is negative 2. I can take that and substitute that back into my first equation. So I have negative 2 plus 7y equals 12. If I add 2 to both sides, that gives me 7y equals 14, and y equals positive 2. So my ordered pair here is a negative 2, 2. Again, we're going to test that in our calculator. If x is negative 2 plus 7 times 2, 7, there we go. That gives me 12, and that's what I should have. On my second equation, I have negative 2 times negative 2 plus 7 times 2, and that gives me 18, and I should have 18. Right? Always verify. Now, if you don't have a calculator at home, remember that there's a graphing calculator in Citrix that you are able to use. All right? And it matches the ones that we have in class perfectly. All right, again, solve by elimination. So on the first one, they eliminated themselves. On the second one, we had to make one work. And on this one, I see that there's nothing that works with x, there's nothing that works with y, so I'm going to have to multiply them both. Okay? So let's see, there's lots of options here. So I can multiply the top by, I can just say by negative 3, and that would give me positive 3. I can multiply just the bottom by a negative 2, that'll give me a positive 2. It really doesn't matter as long as you're equitable, all right? Work things out so that whatever you multiply by, you multiply everything by it. So by multiplying by negative 2, and I could have done negative 3 and gotten rid of x, but let's be different. Let's go ahead and go with getting rid of y this time. So I can go ahead and multiply that out. My top doesn't change, my top equation. But here I'm going to have negative 6x plus 2y equals negative 8. And I see here that my y's are going to cancel. Okay, they're going to eliminate themselves. X minus 6x is negative 5x. Negative 7 minus 8 is negative 15, so that x equals 3. I can go and plug back into my first equation. I have 3 minus 2y equals negative 7, so that negative 2y is negative 10, and y equals 5. So my ordered pair here is 3, 5. Again, use your calculator and go back and verify that that solution actually works. So I have 3 minus 2 times 5, and that is negative 7. And then I have 3 times 3 minus 5, and that gives me 4. Right? So verify, it's an easy thing to do to check your work there. All right, word problems. I know these are your absolute favorite, so let's talk this one through. Write your own equations, then solve. Right? Now some of you are very good at just kind of thinking these through and figuring it out, okay? Which is great, but we're really focused here in this unit on systems of equations, so you must be able to write the system of equations, not just work out an answer by thinking through it or drawing pictures on your paper, all right? So let's think about this. Kara bought 12 paints and brushes all together. So that means we have a total, that's our total, we have a total of 12 pieces of whatever, okay? We have a total of 12. She spent a total of 16, so there's my other total, okay? So right now I'm thinking I've got two totals. If each paint costs $3 and each brush costs 50 cents, how many paints did she buy and how many brushes did she buy? So let's define our variables. Well, the number of paints is one thing that I have to figure out. So that's a variable. I can call that x. And then the number of brushes that I bought. That's my other variable. Remember, two variables, I need two equations. Well, that works out because I have two totals. I have a total of 12 and I have a total of $16. All right? So let's just think about it. How do I get 12? Well, what is 12? Well, that's 12 pieces of art material, right? So how did I get that? Well, I put paintbrushes together with, or I put paints together with brushes, okay? How many paints and how many brushes gives me the 12 things that I bought all together, okay? 16 is a dollar amount, okay, so that's a cost. Well, how did I get $16? Well, the cost of paint and the cost of brushes together gave me $16 total. Well, how did I get the cost of paint? Well, paint is $3 per paint, so $3 for every paint. My brushes are 50 cents per brush, so 50 cents per brush. Okay? So that's my system, all right? So I've got the system, now I have to solve it. It's up to you how you solve it. You can either use substitution, you can use elimination, either of those will work. But I'm going to use substitution here because this kind of lends itself to that. So I'm just going to solve that for x and say, well, x is negative y plus 12. And then I'm just going to plug that in to this equation down here. So 3x, or 3 times negative y plus 12 plus 0.5y equals 16. Well, that's negative 3y plus 36 plus 0.5y equals 16. Negative 3y plus 0.5y, that's negative 2.5y. Minus 36 gives me negative 20. If I divide both sides by negative 2.5, I get y is 8. That means I have 8 brushes, okay, because that's what brushes is. Then I can take that and plug it into my other equation, which is the first equation that I didn't use yet. So x plus y equals 12. So x equals 4. So we're not going to write this answer as an ordered pair because that's not the question. The question is how many paints did I buy and how many brushes did I buy? Well, that means I bought 4 paints, because x is my paints, 4 paints and 8 brushes. Always answer your problem in the context of the question every single time. And then make sure it makes sense. 12 paints and brushes all together. Well, I have 12 paints and brushes all together. Next one is a system question, and understanding that you have some solutions in the double shaded region. Okay, so let's just test them. If it's in the double shaded region, then it's a solution. If it's not, then it's not. So 0, 1. 0, 1, 0, 1 is right here. Okay, now that's on a dotted line. So since it's on a dotted line, even though it's in the double shaded region, the dotted line means that it's not part of the solution set. Okay, so no, that is not a solution. 0, negative 2. That's on the solid line, and solid means it is part of the solution. So yes, 0, negative 2 would be part of the solution for the system of inequalities. Negative 5, 1, 2, 3, 4, 5, negative 3, 1, 2, 3 is right here. Okay? That's definitely in that region, so yes, that is a solution. And then 1, 1, 2, 3, 4, 5. That is not, that's only in the region for 1, not the other. So no, that is not a solution. Remember, the double shaded region is your solution area. All right, last one, number 12. We're going to graph this system of inequalities. Okay. So here we have a slope of 1 and an intercept of 2. And I have a less than sign there. So intercept of 2 is here. Slope of 1, up 1, over 1, up 1, over 1. Okay. And it's going to be a dashed line because it's not equal to. So I'm going to do a dashed line here. Okay, and that's less than, so I'm going to shade less than. Everything is below. Everything below the line there. Okay. Then I'm going to graph this other line. First, we need to get that into slope-intercept form. So 2y is greater than 3x plus 2, and I need to divide both sides by 2. So 3 halves x plus 1. So my slope here is 3 halves, and my intercept is 1. So if my intercept is 1, it's right there. Up 3, 1, 2, 3, over 2, 1, 2. 1, 2, 3, 1, 2. I want some more points. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And this is also going to be a dashed line. And this one is greater than, so we want to shade above that line. Everything above the line. Now I know with inequalities, the solution lies within the point of intersection, okay, where the shading is overlapping. So this whole region right here, where I've got blue and gray, or blue and red, what am I saying gray? Blue and red, that is the solution to the inequality. Feel free to go back and watch it again, pause and review. The keys have been posted online for your review homework, so check those out as well.